Good evening, dear children. Today we are coming up with another revision session for chemistry, CBSE class 12th. Today we are going to do another chapter from organic chemistry module. As you have already completed haloalkanes and haloarenes revision, today we are going to discuss alcohols, phenols and ethers. As per the latest CBSE sample paper, the weightage for this chapter is 6 marks, and it is one of the easiest chapters where you can score full marks. So in this session, my objective is to give you an insight of some of the important topics and the most expected MCQs from this chapter. So without wasting much time, let's start. I believe every one of you can see the screen, and also I am audible to everyone. So please comment in the comment box if I am audible to you and the screen is visible. Right, excellent. So let's start with the first question, the IUPAC naming. The IUPAC name of the given compound here. As you all can see here, in this compound there are different functional groups. You know the basic rule, what we follow when we have multiple functional groups is we need to fix one of the group as the principal functional group, and the remaining has to be treated as the secondary functional groups. So here you can see that there is OH, which is alcohol, there is bromine, which is a halo group, and then there is a double bond, which is alkene. So as per the priority, which functional group should be treated as the principal functional group? Yes, alcohol has to be treated as the principal functional group. So we will start numbering the carbon chain from alcohol attached carbon. So this will be the right numbering for the parent chain, and we will write the name as per the alphabetical order of the secondary functional groups. So here you can see there is a bromine, there is a methyl group. So as per alphabetical order, bromo should be coming first. So the name of the compound will be 2-bromo, 3-methyl, and the parent chain has 4 carbon atoms. So 4 carbon atoms means the word root has to be but, and look at the position of the double bond. The double bond is coming in the second place. So it should be but-2-ene, and the principal functional group is alcohol, so it should be suffixed as -ol. And all of you know that if the suffix is starting with a vowel, we have to drop the E from the parent alkene. So the correct name will be option B. So most of you have written the answers clearly. Very good. Kevin Peter, Aditi, Salaf, Siddharth, Nitin, Reshma, excellent. So I hope this question is clear to everyone. Let's move on to the next question. The following is, all of you can see the compound here. The question is, you need to identify what kind of alcohol is this. So you know the identification criteria. You can see that this is the alcohol functional group. This functional group is attached to a carbon, and you can see that this carbon is connected to how many carbon atoms? There are 3 carbon atoms. So definitely this is going to be a tertiary alcohol. And moreover, you can see that the alcoholic carbon is sp3 hybridized. How do we know? We can find the hybridization by simply looking at the number of sigma bonds that the carbon has made. Here you can see there is 1 sigma here, another sigma here, another sigma here, another sigma here. That means this carbon is going to use 4 hybrid orbitals. And you know the hybridization of 4 hybrid orbitals is sp3 hybridization. And this carbon is in turn connected to another carbon which is double bonded. So looking at this carbon, you can see that the hybridization of this carbon is sp2. So what do you call such alcohols as? Yes, I'm waiting for your answers. An sp3 carbon attached to OH group, which is in turn attached to sp2. Yes, so they are allylic alcohols. So here we can see that it is a tertiary alcohol as well as it is an allylic alcohol. So the right answer will be A. I hope this is clear to everyone. Excellent. Now, I would request all the students to listen carefully, because at the end of the session, we will have a surprise quiz, which will be a live quiz, and all of you will be participating, and immediately after the quiz, you will be seeing the leaderboard, and let's see who is going to come on the top of the leaderboard. Right. So let's go to the third question. Arrange the following compounds in increasing order of boiling point: propan-1-ol, butan-1-ol, butan-2-ol, pentan-1-ol. So let me just brief you about the factors that affects the boiling point of compounds. You know that boiling point is dependent on intermolecular forces of attraction. Intermolecular forces of attraction is dependent on molecular mass, what kind of attractive forces are operating, what is the overall surface area of the compound. These are the main things that decides the boiling point. So you can see here propan-1-ol, CH3, CH2, CH2, OH. This is propan-1-ol. Butan-2-ol, CH3, CHOH, CH2, CH3. This is butan-2-ol. Then we have butan-1-ol, CH3, CH2, 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 OH. This is butan-1-ol. And then we have pentan-1-ol, CH3, CH2, 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 OH. This is pentan-1-ol. As I said, intermolecular forces, the extent of intermolecular forces is what is deciding the boiling point. So here you can see that the longest carbon chain will have the highest boiling point. It has more surface area, it has more molecular mass, and thus it will have the highest degree of intermolecular forces. So pentan-1-ol is going to have the highest amount of intermolecular forces. Then who will be coming next? Then we have 4 carbon chains. Even this has 4 carbon, this also has 4 carbon. Now, when it comes to isomers, you need to remember the factor that decides the boiling point will be again the surface area. You know that straight chain isomers have got more surface area than branched isomers. So butan-2-ol, it is having a branched structure, whereas butan-1-ol has a longest chain structure. So butan-1-ol will have more boiling point than butan-2-ol. And finally, the 3 carbon alcohol propanol in this will be having the lowest. So what will be the right answer? Yes, majority have given the right answer. Right. So propan-1-ol has the lowest, then butan-2-ol, then butan-1-ol, then pentan-1-ol. So I hope this is very clear to everyone. So let me just quickly recap. Intermolecular forces is what is deciding the boiling point. More the surface area, more will be the forces of attraction. So longer chains or straight chain compounds will have longest, the strongest intermolecular forces, and they will have highest boiling point. Right. Now let's go to another question. Reaction between acetone and methyl magnesium chloride followed by hydrolysis will give. So in this question, it is very clear that you are treating acetone. What is acetone? Acetone is a ketone. And methyl magnesium chloride, which is Grignard reagent. So you have studied what will happen if aldehydes and ketones reacts with Grignard reagent. So let me just remind you, if the aldehyde that you're taking is methanol and they react with Grignard reagent, you will get primary alcohols. If you are taking any other aldehyde other than methanol and you treat it with Grignard reagent, you are going to get secondary alcohols. And if you take a ketone, you are going to get a tertiary alcohol. So in this case, what is going to happen? Let's see. Acetone is propan 2-on. This is the compound called acetone. The common name is acetone, and propan 2-on is the IUPAC name. Now it is treated with CH3MgCl, which is Grignard reagent. And all of you know what is going to happen here. The carbonyl carbon is polarized, so there will be a negative charge on this oxygen and a positive charge on this carbon. So this carbon is electrophilic, and Grignard reagent has a positive center on magnesium, a negative charge on the alkyl group. So what is going to happen here? In this case, the CH3 group, which is having a negative charge, is going to attack this electrophilic carbon, and the MgCl is going to attach into this oxygen. So we are going to get an adduct, CH3 CH3O MgCl CH3. This is an adduct. Why do we call it as an adduct? Because it is an addition product. That's why it is called as an adduct. Now they said followed by hydrolysis. So if you hydrolyze this, what will happen? This MgCl will be removed, because you see here there is negative charge on oxygen. So in the medium that we have H plus and OH minus. This H plus is going to attach here with the oxygen, and the MgCl will be going along with or eliminated with OH minus. So what are we going to get? CH3 OH CH3 plus MgOHCl. This will be the byproduct. So what is this compound? Right. Yes, most of you have written the correct answer. This is a tertiary alcohol, and you can see that this group is tertiary butyl group. Right. It is a tertiary butyl group. So you are going to get tertiary butyl alcohol. And I believe all of you know the groups which are listed here: isopropyl, secondary butyl, isobutyl. Is that clear to everyone? Right. Next question. The structure of intermediate A in the following reaction is, I think you might have already recognized this reaction. Yes, tell me, which reaction is this? Yes, very good. This is preparation of phenol from cumene. What is cumene? Isopropyl benzene is what is called as cumene. So when we take cumene and oxidize it, you can see that the first step is oxidation. So what will it form? It will form cumene hydroperoxide. So which option is correctly showing cumene hydroperoxide? Yes, excellent. Reshma, very good. Which option is showing cumene hydroperoxide? That is the question here. Yes, Joel Seji, excellent. Yes, option C. This molecule is what is called as cumene hydroperoxide. And when you hydrolyze it, what will happen? This will be eliminated as acetone, and the OH group will be attached to benzene, and you are going to get phenol and acetone. And this is one of the most important industrially useful reaction, because both the products are very useful, or they have great significance in chemical industries. Right. So let's move on to the next question. Yes, Siddharth, very good. Right. The next question. When vapors of a secondary alcohol is passed over heated copper at 573 Kelvin, the product formed is. This is a very important question and one of the most expected question this year. So secondary alcohols. Let's write the general structure of it. Secondary alcohols are like this: RCHOHR. You know the meaning of secondary means the carbon where the alcohol or the functional group is connected is in turn connected to two other carbon atoms. That is called secondary. So in case of secondary alcohol and you are passing copper at 573 Kelvin, remember this reaction you have studied under the name dehydrogenation. Catalytic dehydrogenation. Why is it called dehydrogenation? Because here removal of hydrogen takes place. So in this case, what is going to happen is this hydrogen and this hydrogen will be removed. And what are we getting after that? We have RCOR. What is RCOR? It is ketone. It is ketone. So here the right answer is ketone. But remember, in this case, if we had started with a primary alcohol, this is a primary alcohol, right? So if we treat primary alcohol with the copper at 573 Kelvin, what are we going to get? Again, dehydrogenation happens and you will get RC double bond OH. What is that? It is an aldehyde. It is an aldehyde. So here, secondary alcohol is going to give you ketone, primary alcohol is going to give you aldehyde. Now tell me, what do you get if you take a tertiary alcohol? What will you get if you take a tertiary alcohol? Yes, I'm waiting for your comments. Primary alcohol will give you aldehyde, secondary will give you ketone, tertiary will give you, yes, Reshma, excellent. You will get an alkene, because at that time, instead of dehydrogenation, you are going to see dehydration, removal of water. So that will give you an alkene. Right. Yes, Sriram, very good. Next one. Which one is the most acidic compound? Again, from Alcohols, Phenols and Ethers chapter, one question will surely be related to acidity. So all of you need to have a crystal clear idea about the acidity of alcohols and phenols. So here the comparison is very easy because all of the molecules given here are phenols and their derivatives. Yes or no? Now, let me ask you, why are phenols acidic? The very reason why phenols are acidic is once they lose the proton, they become phenoxide ion, and that phenoxide ion is very much resonance stabilized. So that resonance is going to help that oxygen's negative charge to be delocalized in the ring effectively. That's the reason why phenols are willing to donate protons more than alcohols. So here all of them are phenols. So how do we make a decision? There you have studied a concept in NCERT. It is clearly written, electron withdrawing groups, if they are present on the ortho and para positions, they help in increasing the acidity of phenols by stabilizing the phenoxide ion formed, right? Whereas electron releasing groups, they are going to make the situation worse. So their acidity will be lesser. So here the question is, who is the most acidic compound? Definitely the compound where phenol has maximum electron withdrawing groups present at the ortho and para positions. And you can clearly see here, yes, all majority of you have given the right answer, option C. That is 2,4,6-trinitrophenol, and its acidity is so high, that's why it's called as picric acid. It is also known as picric acid. Right. Okay, excellent, excellent. All of you have given the right answer. Next. Reaction of phenol with chloroform in presence of dilute sodium hydroxide finally introduces which one of the following functional group? Very important question. You know that in alcohols, phenols and ethers, there are mainly three name reactions. What are they? Core-base electrolysis, Reimer-Tiemann reaction, and Williamson's ether synthesis, right? What is core-base electrolysis? It is a process by which phenol can be converted into salicylic acid. What is Reimer-Tiemann reaction? It is a process by which phenol can be converted into salicylaldehyde. And what is the third step? The third one, Williamson's ether synthesis, where you treat an alkyl halide with sodium alkoxide and you get an ether. So these three named reactions are very important in this chapter. So tell me, which reaction are we talking about in this case? Look at the reagents. It's very easy. Reaction of phenol with chloroform in the presence of dilute sodium hydroxide. Phenol with chloroform, CHCl3 and NaOH. Finally introduces which one of the following functional group? You know that first it will form an intermediate, and this upon treatment with NaOH and hydrolysis you will get CHO here, isn't it? So what is this compound called? This is known as salicylaldehyde. Is it clear? This compound is known as salicylaldehyde. So this is Reimer-Tiemann reaction that you are looking at. So the correct option will be option C. Yes, very good. Okay, the next one. In the following sequence of reaction, CH3Br treated with KCN, you are getting a compound A, which on hydrolysis gives a compound B, which on treatment with LiAlH4 in presence of ether gives C. See, in case of organic chemistry, do not expect that a conversion question will be asked from only one chapter, or it will be strictly focused on, based on only one chapter. You should understand that all these 4 organic chapters that you are studying, all the reagents that you are learning in that, combining that, they will be asking a conversion questions, and there will not be a conversion question asked which will have more than maximum this number of steps that you will be using is 4 steps. There won't be any conversion reactions which will be exceeding that. So in this case, this is a very easy question. You can see that first you are treating bromomethane with the KCN. In the chapter haloalkanes and haloarenes, you have studied about CN minus. What is the property of CN minus? It can act as an ambident nucleophile. What do you mean by an ambident nucleophile? It has 2 nucleophilic sites. It can donate an electron pair through carbon as well as through nitrogen. So it all depends on what kind of reagent are you taking. Are you going to take KCN or are you going to take AgCN? So tell me, if you take KCN, what are you going to see? It will form nitrile. So here we are going to get ethane nitrile. Ethane nitrile. Now we are hydrolyzing this. Complete acidic hydrolysis of nitriles is going to give you carboxylic acids. So what will be the product formed here? You will be getting CH3COOH, which is carboxylic acid. Since there are 2 carbon atoms, this is ethanoic acid or acetic acid. Now we are treating this with LiAlH4 in ether. What is lithium aluminum hydride? One of the strongest reducing agent in organic chemistry, right? One of the strongest reducing agent. You know, we have plenty of reducing agents. Lithium aluminum hydride, sodium borohydride. These are all good reducing agents, but the most strongest reducing agent among them is LiAlH4. So what do you get if you reduce a carboxylic acid? You know that carboxylic acid will get reduced to form alcohol. So the COOH will be reduced to alcohol. And what are we getting here? We are going to see ethanol. So the compound C is ethanol, or commonly known as ethyl alcohol. Yes, H3O plus is acidification, right? Yes, H3O plus is acidic hydrolysis. Clear? Right, shall we move on to the next? Okay, great. Consider the following reaction. phenol treated with zinc dust, you're going to get X, and then that X is treated with CH3Cl in presence of anhydrous aluminium chloride to give Y, and Y is treated with alkaline KMnO4 to give Z. The product Z is, again, phenol treated with zinc dust. What do you get? Phenol, when distilled with zinc, you are going to obtain benzene. And this is one of the most important reaction in conversions, because this is an easy way by which you can reach benzene stage. And you know that benzene can be can undergo electrophilic substitution reactions, and you can produce so many derivatives of benzene. So here we are treating this benzene with CH3Cl in presence of anhydrous aluminium chloride. Tell me, what reaction is that? CH3Cl, that is chloromethane. It is an alkyl halide treated with anhydrous aluminium chloride. What is the role of anhydrous aluminium chloride? It is a Lewis acid. And you all know this reaction is Friedel-Crafts alkylation. And what is going to happen here? This Lewis acid, it's badly looking for electrons. So what will it do? It will break this CH3Cl bond heterolytically, and it will remove Cl minus, leaving CH3 plus, which is carbonium ion. And what will happen to the carbonium ion? It will go and attack the benzene ring. You know that benzene is more prone to undergo electrophilic substitution. And what are we going to get here? We will see that the CH3 group will substitute the hydrogen on the benzene ring, and you are going to get toluene, right? You are going to get toluene. Now, that toluene is Y. And then we are treating it with alkaline KMnO4. Again, alkaline KMnO4, one of the strongest oxidizing agent in chemistry. So this reaction is very, very important, because this is called side chain oxidation. So if you have an alkyl group, irrespective of the number of carbon atoms, for example, it can be methyl, it can be ethyl, it can be propyl, irrespective of the number of carbon atoms, the side chains are going to get oxidized to carboxylic acid. So here, this alkyl group is going to get oxidized directly into carboxylic acid group. So what are we going to get here? The final compound Z is this. What is the name of this compound? Yes, it is benzoic acid. Excellent. Benzoic acid. Right, very good. Yes, Adil, very good. Now, the next question. I think you don't need my help for this question. The correct acidic order of the following is: you have phenol here, you have 4-methyl phenol here, 4-nitrophenol here. What is the rule? Electron withdrawing group increases the acidity, electron releasing group decreases the acidity. So what will be the correct order of the following compounds? So here you can see that the most acidic will be this, then this, and the least will be this, because electron releasing group like CH3 is going to destabilize the phenoxide ion. It won't be as effective as electron withdrawing groups. So what is the right answer? All of you are saying B. Okay, so third one is the most acidic, then the first one, then the second one. Excellent. See, sometimes they will twist this question, and they will ask you, arrange the following based on their pKa values, increasing order of pKa values. At that time, see, you need to be very, very, very vigilant when you read the question. If this question was based on acidity, this is the answer. But if they were asking the question based on Ka value, again this is the answer. But if they are asking about pKa, every one of you know that pKa is equal to negative logarithm of Ka. Negative logarithm of Ka. What does that mean? More the value of Ka, lesser will be the value of pKa. That means an acid who has highest value of pKa will be the weakest acid. Is that clear? The same is applicable in amines chapter as well. They will give you certain bases, and they will ask you, arrange them based on their pKb values, arrange them based on their Kb values or their basicity, like that. So at that time you should be very vigilant in answering this kind of questions. Hope that is clear to everyone. Excellent. So here the answer is B. Right. Now the next one. What is formed when a primary alcohol undergoes catalytic dehydrogenation? We already answered that. I already told you. What will you get if you dehydrogenate primary alcohol? Yes, we get an aldehyde. Again, primary alcohol will give you aldehyde, secondary will give you ketone, tertiary will undergo alkene formation. Is it clear to everyone? Right. Let's go to the next question. The compound which reacts fastest with Lucas reagent at room temperature. Tell me everyone, what is Lucas reagent? What is Lucas reagent? Lucas reagent is anhydrous zinc chloride plus concentrated HCl. This is Lucas reagent, and you know that it is a test for distinguishing different types of alcohols, right? Different types of alcohols. Now, you know the reaction what is happening here. In this case, it is proceeding through a carbocation formation. So, you should look at whose carbocation is most stable. That will be the one who will react quickly with Lucas reagent and form the corresponding chloroalkane. And you are going to get the turbidity depending on the reactivity. For example, ROH plus HCl. This is what is Lucas reaction. Anhydrous zinc chloride catalyst. So you will get RCl plus H2O. This is the reaction. So whose carbocation, which alcohol's carbocation is most stable, that will form turbidity immediately. So you know the order. Tertiary is greater than secondary is greater than primary. So a tertiary alcohol will react faster with Lucas reagent, right? Now all you need to do is just identify who is a tertiary alcohol here. Yes. Yes. Lucas reagent is used to identify differences between alcohol. Yeah, very good. Yes. So which is a tertiary alcohol here? Okay. All of you are saying, Samuel is saying D, Reshma is saying D, Nitin is saying D, Zalaf is saying D. Yes. 2-methyl propan, this is propan 2-ol, that is a tertiary alcohol. You know, if we make the structure of that, propan means 3 carbons. Let's number the carbons 1, 2, 3. 2-methyl, we have a CH3 at the second position, then 2-ol, which means we have an OH at the second position, and this is tertiary butyl alcohol or 2-methyl propan 2-ol. This will be the fastest. Is this clear? Right. Now let's go to next question, which is very easy. Lucas reagent is, we already discussed that, it is concentrated HCl and anhydrous zinc chloride. Anhydrous zinc chloride. Okay, let's move on to the next question. This is another question or another area where you are going to get a question for sure. The breakage of ethers with the help of hydrogen iodide or hydrogen halides. So the question is, anisole on cleavage with HI gives. Okay, here we have a doubt. What is the difference between anhydrous and hydrous? Hydrous means in presence of water. You will have water content in that. Anhydrous means without water. Say for example, you have hydrated copper sulfate and anhydrous copper sulfate. Anhydrous copper sulfate is just CuSO4. Hydrated copper sulfate is CuSO4.5H2O. So if you have water content in that, we call it hydrated. If you don't have, we call it anhydrous, kind of dehydrated condition. Is it clear? Okay, great. So what is anisole? Anisole is methoxybenzene, OCH3. Then we are treating it with HI. So here you know that in the breakage of ethers we have two possibilities. This bond can break and attach with iodide, or this bond can break and attach with iodide. Tell me, where and how will the breakage happen if one of the group is an aromatic benzene ring? Yes, you know that it is difficult to break this bond as it has a partial double bond character due to resonance. So all the time if you have an aromatic alkyl ether, one of the product will be definitely phenol, and the other product will be an alkyl halide. So we get phenol plus iodomethane. Phenol plus iodomethane. Is it clear to everyone? Yes, very good. Right, let's move on to the next question. The compound that is most difficult to protonate. What do you mean by protonation? Introducing or attack by a proton. What is a proton? H plus. What is H plus? H plus is looking for electrons. So if they ask you which is more difficult to protonate, it will be the one who has less chance of acting as an electron donor. So let's analyze all the molecules here. You don't have to worry about the complexity here. This is all easy. What is this molecule? This is phenol. Benzene ring with a OH. Then we have water, H2O. Then we have methanol, CH3OH. Then we have ether, CH3O, CH3. Okay, think and answer. Here, a proton's attack means if you give a proton in this mixture, what will the proton look for is the lone pairs on oxygen. You know that oxygen has lone pair of electrons. If those electrons are readily available, then that will undergo protonation faster, right? So think, who will have a difficulty in undergoing protonation? Some are saying B, D. Yes, others, I want to hear from you. See, think, you have an aromatic ring here, right? This aromatic ring, what will it do? It will undergo resonance. So this lone pair of electron will be entering into resonance here, right? As a result, you will see that this oxygen's lone pair availability will be much lesser compared to all these three guys. Yes or no? So phenol is the substance who is going to undergo, or who is having a hesitation to undergo protonation. Did you understand that concept clearly? Because the lone pair on phenol is not easily available due to resonance. Therefore, we can say that option A is the right answer. Is that clear to everyone? Kevin, Joel, Shahir, Reshma, Zalaf. Is it clear? Okay. Next one. The major products C and D formed in the following reactions respectively are, again it's a breakage of ether, right? So I think this you can answer. Okay, tell me the answer quickly. I'll just expand the structure here. CH3, CH2, CH2, O, CCH3, CH3, CH3. And you are adding HI, excess HI. Okay, so option B is the answer that many are saying. Option A is the answer that, who is saying, yeah, Reshma is saying answer A. See, in the breakage of ethers, you know the rule. If the alkyl groups are primary or secondary, then the reaction will be following SN2 mechanism, and the least bulky group will be the one who will go with the halide, because the I- is a nucleophile and it will find it easy to attack the least sterically blocked carbon. But if one of the group is a tertiary group, you know that it will proceed through SN1 mechanism, and definitely that tertiary part is going to become the halide, and the other part will become the alcohol. So if you look into that aspect, we will see that the bond will be cleaved here, and you will have CH3, CH2, CH2, OH plus CH3, C, CH3, CH3I. Correct? Yeah, Joyle is saying because of carbocation. Yes, because tertiary carbocation is more stable, so it will proceed through that SN1 pathway and undergoes substitution. But this is not the answer. Here there is a part which you are missing out. Did you see this? Excess HI. Every time you see that excess HI, remember, alcohol which is formed in the first step is again going to get converted into halide. That means even this will, the first alcohol which is formed here, this will further react with the HI, will form CH3, CH2, CH2I. That means you are going to get two iodoalkanes. Remember, if this question didn't have excess HI written on the arrow, it's just HI, then your answer would be B. But here it is excess HI. Did you get it? All of you understood that? Okay, excellent. So we have the correct option. Option A. Right. This is a very important question, okay? This is a very important point. Remember, if it is excess, if the hydrogen halide is excess, it will, even the alcohol will also turn into the haloalkane. It is there in your textbook. That's why I keep on telling you that, before you go for the board exam, at least 3 times you should read the NCERT textbook. And there are 2 benefits. One is, of course, it is going to help you in board exam. Second, if you are planning to appear for NEET, NCERT should be your Bible. Line by line, table by table, everything in NCERT should be thorough. And then a little bit tricks of time management and marking the responses in short period of time. This is going to help you a lot in cracking so many competitive exams. Right? Okay. Now let's move on to the next question. The reaction can be classified as, okay, quick. It's very easy. You can see that there is an alcohol, it is treated with sodium hydride and you are getting sodium alkoxide, and then it is treated with iodomethane and you are getting an ether. Which reaction is this? Under which category do we put this reaction? Yes, RX, alkyl halide plus RONA is going to give you ROR plus NaX. Which reaction is that? This is Williamson's ether synthesis. And dear children, you remember in Williamson's ether synthesis, there is a very important condition that you need to remember. The alkyl halide that you should take must be preferably a primary halide, because this reaction is a nucleophilic substitution. Who is the nucleophile? RO minus is the nucleophile. This nucleophile is going to attack this carbon, and you know that if the nucleophile has to come and attack this carbon should be less sterically blocked. So which kind of carbon is less sterically blocked? Primary carbon. So that's why we say in Williamson's ether synthesis, the best combination is alkyl halide should be primary and the alkoxide can be any. Right. And you know the reverse also. What will happen if you are not taking like that? What will happen if you have a tertiary halide reacting with an alkoxide like CH3ONA or C2H5ONA? What will happen? There will be a question coming. Should I go for substitution or should I undergo elimination? So their elimination will compete over substitution. Right? Because you know the alkoxide is a strong nucleophile and it is going to abstract a proton from the alcohol, which will make the alcohol to go to the elimination process. Is that clear to everyone? Right. So this is Williamson's ether synthesis. Okay. Let's move on to the next question quickly. Identify Z in the sequence of reactions. Come on. CH3, CH2, CH double bond CH2. It's an alkene and you are treating it with HBr in presence of peroxide. Come on, HBr in presence of peroxide. When you see that, your hippocampus should recollect and tell you that it is going to be an Andy-Markovnikov's addition or a Karash effect kind of addition, isn't it? So where will the HBr add? HBr will add in such a way that the negative part of the addendum, who is the negative part of the addendum? The negative part of the addendum is Br minus. It is going to add into that carbon which contain more number of hydrogens. This is Andy-Markovnikov. So you will get CH3, CH2, CH2, CH2Br. And what are we treating it with? We are treating it with C2H5ONa. You see, it's a primary halide and it's a sodium alkoxide. So you're going to witness Williamson's ether synthesis here. So you'll get CH3, CH2, 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 O, C2H5. What is the right answer? CH3, this can be written in a condensed format as CH2 thrice, O, CH2, CH3. Yes, this will form ethoxybutane, right? This is the lowest alkyl part, so this will become alkoxy and this will become alkane. So it is ethoxy. The next one. Among the following ethers, which one will produce methyl alcohol on treatment with hot concentrated HI? Methyl alcohol. You want to get CH3OH. Okay, let's analyze. In the first ether, you can see that there is a tertiary group here. If there is a tertiary group, without having a second thought, you can say that the I minus is going to attack here and the H will go here. So you will get CH3OH in the first molecule itself. But look at the second molecule. Can someone tell me what will happen if I treat HI with the second molecule? You have two alkyl groups here. I will go with the lowest alkyl group because it is least sterically blocked, whereas this will become the alcohol. And over here again, this will become the alkyl part and this will become the alcohol part. And again here, this will become the alkyl part, this will become the alcohol part. Is that clear to every children? If the alkyl groups are primary or secondary, just look for who is less sterically blocked, who is having less steric hindrance. That will become the halide. But if one of the groups is tertiary, then SN1 will operate and tertiary will form the halide. The other will form the alcohol. Clear to everyone? So here the answer is A. Okay, good. The next one. The compound which does not react with sodium is, you know, sodium is a metal. Metals are basic. So if it has to react with something, it should be something acidic. So look at the compounds given here. They have given CH3COH, which is acetic acid, CH3CHOH, CH3, which is an alcohol, CH2H5OH, which is again an alcohol, CH3OCH3, which is an ether. So tell me quickly, who will not react with sodium? Very easy. Sodium's reaction will be with a substance who has an acidic hydrogen or an active hydrogen. Who doesn't have active hydrogen here? Come on, quick. Very good, Abin. Very good. It is CH3OCH3. Why? Because it's an ether. You can see that clearly this ether don't have an active hydrogen. But on the other hand, look at CH3COH. CH3COH, if you treat it with sodium, this active hydrogen is there, which will result in formation of CH3COONa plus H2. Same is the condition for the next one also. CH3CHOH, CH3. This is an alcohol. So this will again have an active hydrogen here. So this will form CH3CHONa, CH3 plus H2. Displacement is going to happen. C2H5OH, CH3CH2OH. Again, this is ethanol. It has an active hydrogen. So you will have CH3, CH2, ONa plus H2. Is it clear? So here, primary alcohols will be more reactive with sodium than secondary, than tertiary, based on the stability. So D does not react. So D is an ether, it does not have active hydrogen. I hope that is clear to everyone. Any doubts in that? Okay, great. Let's go to the next question. Which one of the following on oxidation gives a ketone? Which one of the following on oxidation gives a ketone? Quick, we have already discussed this. Who on oxidation gives ketone? Primary alcohol is going to give you aldehyde. Secondary alcohol is going to give you ketone. Whereas tertiary alcohol, it's difficult to oxidize without breaking the carbon-carbon bond. You have studied that. Primary alcohol will give you aldehyde, secondary will give you ketone. But tertiary cannot be oxidized. So 22nd question, answer is B. Right. Yes, most of you have answered it. Very good. So let's move on to the question. Next question. Quick. Which of the following compound is aromatic alcohol? What is aromatic alcohol? Alcohol group attached to a carbon which should be in turn attached to an aromatic ring. Look at the first compound. The first compound is phenol. It's not aromatic alcohol. The second compound is having an OH attached to CH2, which is in turn attached to an aromatic ring. So this is aromatic. Now the second one, again the same condition is satisfied. So this is also aromatic, but here it is phenolic OH. So who all are aromatic? It is B and C. So option C is the right answer. I hope it is clear to everyone. Okay, excellent. Now, the CO bond length in phenol is less than that in methanol due to, it's a very, very important concept, very important question. The CO bond length in phenol is this, and methanol, CH3OH. Here carbon oxygen bond length, that's what they are talking about. So whose bond length will be, or it is already given, phenol is less than that of methanol. So what is the reason for that? Yes, of course, one reason is the resonance, because of which there will be a partial double bond character for this bond. And you know that double bonds are shorter than single bonds. So here it is a pure single bond, here there is a partial double bond character. And more than that, there is one more reason. This carbon, if you look into benzene, it's a sp2 hybridized carbon. It's a more electronegative carbon. Whereas this carbon in methanol is an sp3 carbon. So both those reasons account for the shorter bond length in phenol. So what will be our correct answer? Option D, which is both A and B. Okay? Great. We'll do one more question and let's go for the test or the quiz. Which is the correct order of acidic strength of the following? So who all or which all species do we have here? C6H5OH, which is phenol, H2O, which is water, ROH, which is alcohol, and CH triple bond CH, which is ethine. You know, ethynes are also acidic, alkynes are also acidic. Why? Because in ethine, CH triple bond CH, it has an sp hybridized carbon. So sp hybridized carbon means the electronegativity of this carbon is very high. So there will be a huge electronegativity difference, which will make this ethine to release that H as H plus. So ethine is acidic, but you know it's not that acidic compared to other regular acidic substances. So ethine is the lowest in terms of acidity. Now coming to phenol, water, and alcohol. Tell me quickly, what will be the correct order? Yes, phenol is most acidic. Then we have water, then we have alcohol, and then we have alkyne. If you have a doubt in this, that would be alcohol and water, and you know the reason for that as well. Look here, H2O and ROH. Imagine this H plus is gone from both of them, so they both will have a negative charge on oxygen, yes or no? So you know, for charged species, the one which has the least charge, or the one who has the delocalization of the charges, will be the most stable. So here, alkoxide ion and hydroxide ion, comparatively alkoxide ion is less stable Why? Because of the plus I effect of R, it will pump more and more electrons into the oxygen, which makes the situation worse. So in hydroxide, it is not happening so, because hydrogen is neither plus I or minus I. So water is more acidic than alcohol. So our correct answer is option A. Have you all understood this clearly? Okay, great. So let's move on to the interesting session. Let's see who is going to be on the top of the leaderboard today based on the topic alcohols, phenols and ethers. So I want every one of you to go to the link which is given in the comment section. It is pinned at the top. You have to go to that link in your phone. Okay, you all have your mobile phones with you. So if not, please go and take it and log into that site. You don't have to do any registration or anything. Just enter the site address in your browser and then please enter the code which is listed there. So please go and get your phones and enter into the portal. Okay, I can see 16 have already joined. Come on, others, please join fast. "21, come on, join fast. Get your phones, go to the website, enter the code. We're going to start the quiz. "24. All of you can see the code in the comment section. The link is also there. Take your mobile, enter the website, enter the code. 26 are already there. Right, you can look into the screen in your phone. We are going to start the quiz. The one who answers the fastest will be getting a bonus point also. So here is the question. In your phone you can see the question. Select the right answer. CH3CH2OH can be converted into CH3CHO. Ethanol can be converted into ethanol by. Come on, you have 9 seconds left. Yes, time up. You can see the answer is C. The right answer is option C. It should be a mild oxidizing agent. So it should be pyridinium chlorochromate. Right, let's go to the next question. Are you ready? Here comes the second question. On your screen. Monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH yield. Monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH yields. Right, 2 seconds, 1 second, time up. So 8 people have given the correct answer. It's option D. You know, monochlorination is going to do a substitution first, followed by NaOH treatment is going to attach an OH instead of Cl. So you are going to get benzyl alcohol as the product. So you got the idea of this game, right? So you are having 30 seconds. The one who answers the question faster, it's not the one who is answering the correct answer, the one who is answering the question faster is going to get bonus points. So it all makes a difference in your leaderboard score. So let's have a look into the leaderboard. So here we have Dharani on the top. Then there is Mars. I don't know who is Mars. Your parents have given you really good names. Why don't you put your scientific name there instead of your common name? Right, and then we have Meet, and then we have Faisal. Okay, that is when 2 questions are over. Let's move on to the next question. Are you ready? Great. So here comes the third question. Look at your phone. What is the correct order of reactivity of alcohols in the following reaction? Come on, Lucas test, we just discussed it. No one should make a mistake. Time is running. Time up. Still we have errors in this. I can't believe that. We just discussed this question today and you made a mistake. 13 have made it correct. Right, let's go to the next question. Question number 4. Look at your phone. Question is there in your phone. Arrange them based on the decreasing order of strength, of acidic strength. Five seconds. 4, 3, 2, 1. Time up. Okay, great. Majority have made the answer correct. Very good. That was a very important question. The order of acidity. Let's go to the last question. You know, we don't have much time, so we have only 5 questions here. So the last question on your phone. Which of the following cannot be used to convert RCHO into RCH2OH? Which of the following cannot be used to convert aldehyde into alcohol? Hydrogen in palladium, lithium aluminium hydride, sodium borohydride, reaction with RMgX followed by hydrolysis. Time up. Okay, again, many of you have made it correct. Let's look into the final scoreboard. Who is leading? There is a slight twist. Faisal is on the top. So Faisal is the winner in today's quiz. Congratulations, Faisal. Keep it up. Very good. See, the main reason why I want you to do this today is to give you an idea about what is the difference between board exam and competitive exam. If I had given a little more time, the timer was set for 30 seconds. If I had given a little more time for you to think, I'm sure that majority of you would have made all the 5 questions correct. Yes or no? Time was the problem. You were having all that adrenaline rush in your body while answering that question. You were simultaneously thinking about the question's answer as well as the time. So this time management skill is what you have to learn for competitive exam preparation, and in board exam you are focusing more on the theory part. So keeping these 2 tracks parallelly will definitely help you to excel in both of them. So basically the difference in competitive exam preparation and board exam is this: your time management skills. That matters a lot. The one who answers 180 questions in NEET examination in the shortest period of time and completing that paper with correct answers and less negatives is going to be the top, or going to be on the top. So this is what everybody need to realize, and I'm sure all of you will be continuing your sincere efforts for preparation towards the board examination. The next day, that is tomorrow, we will be coming up with another interesting session from another subject. Until then, this is Danesh Venugopal signing off. See you all. Good night.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.